Thank you, Verity, and thank you everybody for making the effort to get down here to the town hall, which I do feel the heat in, and I'm wearing my Melbourne attire in my suit, and obviously it's not as common in Perth as in Melbourne. And thanks to all the SEN team and the people who, the Beyond Zero Emissions Perth team who put the event together. Fantastic work. Obviously you're worried you'd half fill the town hall, but you did a bit better than that, so great work there. And of course I'm here to talk about the Zero Carbon Australia project, which includes the stationary energy plan which was released, and that's a plan for taking the entire Australian economy to 100% renewable energy. So it's one scenario exploring how you could do that if we chose to do so. So obviously you can have an economy run predominantly on gas, or on a combination of coal and gas, or on hydro and gas and so on. We've done a scenario for running the economy on 100% renewable energy. And we've shown that if you lined up your resources, if you signed on the bottom line on the cheque, you could do it in a decade if you wanted to. So it's a project management timeline. Just some quick context, Angela Merkel's climate advisor, so that's the Conservatives in Germany, and the EU's climate advisor is Professor Hans-Joachim Schellnhuber. He's the head of the Potsdam Institute on Climate Science, Climate Research, and he actually released a paper last year where he showed that if you wanted to have a 67% chance of avoiding 2 degrees Celsius, which many say is too high, because regionally in Australia that could mean 4, 5, 6 degrees average increases. You needed to decarbonise an economy like the USA by 2020. Now Australia has the same sort of emissions profile as the USA. So we didn't want to sit around and debate the topic because we thought it's pretty important to get on with the job. We put together a crack team of young, smart, switched on engineers, physicists, people who work in industry, they work in the fossil fuel industry, they work at refineries, they work in major engineering companies, and together they wanted to design the future that they wanted to work in. So equally at the same time there's another group walking the halls of parliaments around the country, and they're in and out of politicians' offices, but unfortunately it's not us, it's the Can't Do campaign. And the Can't Do campaign, the oil and gas industry, the generators, the coal exporters. And they sing the Can't Do mantra, and the Can't Do mantra is that renewable energy can't supply baseload. Renewable energy is too expensive. Renewable energy will wreck the economy. Renewable energy will cost jobs. So we put together the Can Do team, and you can see here at our university launch of the plan, a little while ago, we were all there. There's a bunch of the young people, the Melbourne team, but we've actually got teams all around the country, and we put together the project. So this is pro bono research put together by people who are donating their time. And we've got research partnerships with the University of Melbourne, 2 divisions in there, and also we're now recognised training for anyone who wants their Engineers Australia certified professional development done. Our stationary energy plan is a part of 6 plans. We include all sectors of the Australian economy: transport, buildings, industrial processes, land use, and replacing fossil fuel export revenue. We're also following on with documents on policy options, research directions, and commercialisation opportunities. So what I'm talking to you today about is the stationary energy plan. That's the power for the lights, the projector, for the aluminium smelter, and so on. We've had some pretty good exposure with this. Here's a Q&A panel we did with the Business Council of Australia Chief, Bob Carr, the Sun King, Sheng Rongji, now the 3rd richest man in China, and Kate Blanchett and Tony Jones. This was at the Wharf Theatre and screened on ABC television a fortnight ago. We've had pretty good luck. Dr. Carl's been spruiking us at every opportunity. In fact, today he was on ABC The Drum television program on ABC News 24 talking about Dr. Carl's energy plan, which happens to be the same as our energy plan. So we're okay with that. We're into that kind of sort of advocacy, so if he wants to adopt it, it's fine. David Suzuki has got so into the plan. Here he is talking to our radio program live from the Sustainable Living Festival, and he's got $2 million. He's going to do a similar research project but employ researchers. We've convinced him to adopt the model of using only research coordinators and getting an army of pro bono people from industry to do the work to get the job done. So he's going to follow the model with Zero Carbon Canada. We've given the presentation to the International Energy Agency, and you can find a write-up on their website in their news section. And so that was in January. We presented it at the IEA, and the Renewable Energy Divisions endorsed the project. And we've got this fantastic model just as showing off. I'll show you what that is. It's a solar thermal plant. And the big key to an Australian 100% renewable energy plant is solar thermal. And that's the real one, and that's our model, 400 to 1. So that's a baseload solar thermal plant, and I'll tell you how that works. So when I say baseload, I mean solar power all through the night, solar power around the clock. It's 24-hour solar power. So here's how it works. A sea of mirrors, a field of mirrors surrounds a central tower. The light of the mirrors, each individually tracked mirrors, is bounced up to the top of the tower, where a fluid travels up the tower from the cold storage tank. There's 2 tanks at the base of the tower. So the liquid is molten salt, it's industrial fertiliser. It travels up to the top of the tower, receives the light from the field of mirrors, we're talking 17,000 mirrors, say, and it's then banked in the hot tank. So it starts at 290 degrees in the cold tank and arrives at 565 degrees in the hot tank. It's the same temperature that a coal-fired power plant works at. So it's like Grandma's thermos. All the heat is stored up in a big tank of molten salt, and then any time, day or night, that you need electricity, water is run past the salt through a shell and tube heat exchanger, flashes to steam, and drives a conventional turbine, the same turbine in a coal, gas or nuclear plant. So for grid operators, it interacts with the grid exactly the same as the kind of power plant they know how to run. So it's 24-hour solar power. Now this is what the molten salt looks like when it's not molten. This is before the big melt. It's just potassium nitrate and sodium nitrate. Here I'm holding the potassium nitrate. It's pretty safe. If you don't inject it, you're okay. Wash your hands afterwards. You don't need an EPA licence in the United States because it's industrial fertiliser, so it's accepted to use and it makes planning, fast tracking pretty easy. And here's Patrick, he's the first zero carbon research fellow in Australia. He's at the University of Melbourne Energy Research Institute, and here he's like a pig in shit at a baseload solar thermal plant. You can see the tanks behind him. He's a chemical engineer. I found him roaming aimlessly around the ExxonMobil refinery. Took a pay cut, half the pay, and said he'd come work for us, and he's really happy now. So here's the point that you need to take into note. Unlike wave, there's a great company here called Carnegie, or geothermal, hot rocks geothermal, this is not something that's in test phase, development stage, commercialisation opportunity. This is prototype in 1980. So in the USSR built this really USSR-looking tower in 1978, 5 megawatts. The Americans had to beat them, one-up them by doubling it at 10 megawatts in 1981. And the French just got smart and they made a molten salt tower in 1982 and had 4 hours of storage to show that you could run it after dark. Follow on to 1996, the US, not to be outdone by the French, added more and more mirrors and added 4 hours of storage to their test plant, their commercial operation test, and it was run together with Sandia National Laboratories. They're the guys who made the nuclear bomb in Albuquerque, New Mexico, Lockheed Martin, Bechtel, Boeing. So not hippies, we're talking defence contractors, people who sort of bomb people and on the side they do solar. Okay? So if we can encourage them to do more solar and less bombing people, it'd be a good thing. So out of that, we've got Senair in Spain, and Senair is Spain's biggest engineering company. They're like Worley Parsons plus a bit of Lockheed Martin. They do aerospace and regular engineering for oil and gas industry. And they're building the solar thermal plants in Spain out of that US Department of Energy program. And their construction contractor is ACS. And guess what? ACS owns Leighton Holdings. So it's not hard for us to do the technology transfer to Australia to build these, to start rolling them out. Because if ACS's parent is the biggest builder of solar thermal plants in the world, Leighton's parent is the biggest builder, then we can do it in Australia. Solar Reserve, on the other hand, United Technologies Corporation, 16th biggest company on the NASDAQ. Pratt & Whitney is the division. They keep half of the world's jet planes in the air. If you trust Pratt & Whitney with your aeroplane flight, or you trust them with your power sector. And their construction contractor in the United States is, their engineering contractor is Worley Parsons. So another strong link here to Australia. So again, we can do it in Australia. So there's lots of companies. There's about 10 plants operating with 7.5 hours storage. They're called parabolic troughs. They don't work so well in winter, further away from the equator. So we've gone with plants like Torosol's Cema Solar, which is down the bottom here, which supports 15 hours storage and has a 75% annual capacity factor. So to compare that to, say, New South Wales black coal plants, they average 63% capacity factor. These plants do 6,500 hours out of 8,000 hours a year. So this is more base load than New South Wales black coal plants. So it runs around the clock most of the time, take it out for maintenance and so on. This is what a heliostat mirror looks like, 130 square metres, and that's Patrick, Rebecca and I, one of them. It's the same size as my house. Get 17,000 of them pointing at the top of the tower, and you need Pratt & Whitney's expertise to handle the heat. And that's what it looks like. He's not standing in the focus because it disappear. And you can see the glow. We didn't touch it up digitally. When you get 500 times the sun on little particles of dust in the air, you get that beautiful look at the top of the tower. This is a plant under construction. I visited it in September. You can see in the foreground, pedestals are not laid out just here. That's the picture from September 27, and that's the picture from December the 2nd. So really fast to roll out. We're talking construction times 12 to 18 months for these to be commercial. Unlike a nuclear plant that takes 10 years and it's a decommissioning nightmare. So here you've got, they use car stamping techniques, so car component manufacturing tricks to make the plants cheaper. So they stamp out pieces like the car doors. There's a $20 billion rollout in Spain right now in solar thermal. So it's separate to their subsidies for solar photovoltaic and for wind. They're especially concentrating on solar thermal because they know the Chinese have got the jump on them on solar panels. So they've moved away from photovoltaic and into solar thermal. And they want that dispatchable power. They want the 24-hour ability to provide the complementary power to wind. $20 billion over the next 3 years. This is not tut-tut a few solar panels on a local school. This is a major industrial mobilisation. So we wrote the Stationary Energy Plan to show you can do it. It's endorsed by the former Chief of Defence, Peter Gratian, by Robin Batterham, the former Chief Scientist of Australia under Howard, and many others. And here's a quick rundown of the actual energy that we deliver in 2020. You can see our starting point here. The blue area is existing electrical services like the aluminium smelter and the projector, and we have a major energy efficiency program which we're writing about currently in our Buildings and Transport Plan. And that energy efficiency program allows us to reduce our absolute delivered energy out to 2020, so we're mining savings in energy. We'll still be using more energy per head of population than Germany in 2020. Now you might think, well, those Germans live in caves, if a Mercedes is a cave, and they've got the second biggest car manufacturing industry. They do aluminium smelters, they've got steel mills, so they're a big industrial, diversified economy. They can be very powerful and very heavy industry on less energy than we'll be using under this plan in 2020, so we can do it too. We're not that hopeless, right? I mean, we might have a complex, but I don't think we're that hopeless. So here in the yellow is other fuel electrification. That's switching our current gas, space and water heating and industrial heat to electricity. So we're using renewable ambient heat or heat pumps. So you buy 1 bar radiator worth of heat and you deliver 5 bar radiators worth into a premises using the best Japanese high efficiency heat pumps and so on. And that's the orange sector. And in the red sector, it's transport electrification. It's rolling out new rail in our cities, significant rail rollout, not seen since the turn of the century, using modern 100-man equivalent automatic track laying machines and electrifying our vehicular fleet. So upgrading our car manufacturing plants to build pure electric or plug-in hybrid electric vehicles. So we're actually delivering more electricity in 2020 overall, but that's because we've now accommodated all energy. That's the 3 sectors: the liquid fuels for transport, which is currently oil and gas, the gas used for space heating, domestic and industrial, and water heating, and the electrical services. So here's our current delivered energy in Australia. You can see oil is the biggest component in the middle, gas, a bit of coal up there for making steel using the outdated blast furnace method. And down here you've got current electricity delivered. So we're delivering more electricity, we're using more bioenergy because we're replacing our steel mills with direct reduced iron, and we're providing some range extension for vehicular fleet and agricultural machinery. So here's what it looks like. 60% of Australian energy from molten salt power towers. Think of a huge smokestack without the smoke coming out of the top. Think about 19 of them in a solar region like Kalgoorlie, where we're going to speak about this tomorrow night. 19 towers. Currently, if you go to Latrobe Valley in Victoria, there's 22 towers with smoke coming out of the top. This is a region, 12 around the country, 19 towers, surrounded by a sea of mirrors. To give you an idea, from the base of the tower out to the perimeter is about 2 kilometres. So if you go any further than that, not enough light strikes the tower, and that gives you a 217 megawatt net tower. Or to compare it, people always like to quote the gross amount, 250 megawatt tower. So each module, each region will have 3,500 of these towers, 12 across Australia. On the wind front, just 6,500 turbines at 23 sites will give us what we need. These are 7.5 megawatt wind turbines from Enercon. They're about 3 times the size of what's currently installed in Australia. And I'd argue you go with the biggest turbine because there's no reference on the horizon. A big turbine's a big turbine's a big turbine. Why install 2 megawatt ones when some sectors of the economy don't like the look of them, when you can install a 7.5 megawatt one that looks exactly the same and produces 3 times the power? Because your eye can't tell the difference. So 6,500 of those, and each wind region would have 2,000 megawatts, or about 270 to 400 turbines. We've already got proposals for wind farms that big in Australia. And this is what 7.5 megawatt turbines look like. Like I said, they look pretty small. There's me in the foreground, and they're a couple hundred metres behind me. And I really like them, actually. And we designed a grid with Sinclair Knight Mertz, and we put that together, and they did a review of that, and you can see that we've linked the west to the east. Currently in the East Australian grid, electricity flows south from Queensland, where they've got a surplus of energy generation, towards Victoria and South Australia. Under this system, we're actually sending the power from the west into the east, so with net generations in the west, and we're exporting towards the east. And we basically showed that you can cross the Nullarbor and only lose 3% per 1,000 kilometres using high voltage DC cables. So pretty good efficiency there. Now version 2 will be reviewing that and seeing if we can optimise our transmission system. So this is the electricity system we could have, or the energy system I'm saying for the whole of Australia, that we could have in 2020 if we chose to do so. So that's our choice. We choose to do that. If we choose to do it in 2025, we could do it as well. If we run the project out too long, we lose economies of scale and the price goes north. You've really got to build them like you build roads. One project after another, so your workforce moves from project to project to project. You save 30% by doing that. And so here's the modelling. We modelled it. That's our demand, scaled up to 2020 with all that extra liquid fuels conversion to electricity, with all the ambient heat and all that driving the heat pumps. There's wind coming in as the first dispatch. You take it as soon as it's generated. There's the firming power, the energy security you get from the solar thermal with storage that's available on demand dynamically, like a gas turbine or a hydro dam, but of course renewable. The existing hydro, very small amount. And some bioenergy backup where we're co-firing the molten salt tanks. And we haven't been fair to the system because we only got wind data from South Australia, Victoria and Tasmania at hub height for our first generation of this plan. And next generation of the plan we're adding WA, New South Wales and Queensland in, which will probably eliminate or near eliminate that bioenergy co-firing of the molten salt in winter there. And this is the excess, so we had to overbuild the system in order to meet the winter peak, and that's 25% of the power that we can't use. So if we can optimise this in the future to eliminate that excess, that'll reduce the overall costs. And one option there is seasonal storage using pumped hydro between existing dam networks, such as in Tas and Snowy, and if there's any opportunities in WA. So we said it's a big manufacturing and construction job. CST scale up, 600,000 heliostats or big mirrors a year. We sell 1 million cars a year. A car's a hell of a lot more complicated than a single mirror. 30 concrete towers, takes about 6 weeks to continuous pour one of those towers like this Loy Yang power station in Victoria, same height, same sort of tower, maybe make it a bit prettier, but that'd be the go. And about 30 people will do one of those. 4 of these Enercon factories, it took 1 year to tool up in Portugal. Equivalent of that will get the job done. We did a detailed labour requirements study and found that we'd only need a peak of 70,000 construction workers. So 70,000 construction workers. Before the GFC, Australia's construction industry was growing at 50,000 per annum. So we could easily provision a peak of 70,000 construction workers to work on this over a 10-year period. And in terms of operations and maintenance, it's twice the amount of workers provisioning energy to our domestic energy sector today. So twice the amount of workers, but we're saving on fuel because we don't have international price parity anymore. We're not linked and beholden to what Colonel Gaddafi does in Libya. We get to control our energy destiny by using free fuel from the sun and the wind. So 190,000 jobs currently in mining and energy in the ground at the bottom versus 1 million in construction. So let's put it in context. The ZTA 2020 plan at the top, peaking at 170,000. So, you know, it's pretty similar to what's going on in mining and energy, and pretty good for our future prosperity. We did a detailed resources requirement. 8% of the nation's concrete would be required, so expand concrete production by 8%, or we find 8% savings. Steel, about 20%. But if you take into account our net steel from iron ore exports, it's like a sliver. So we can easily do that. We used the cost reduction curves of the US Department of Energy to show what would happen when you start building plant after plant. We took into account exchange rates, labour costs, and of course what's going on internationally with the rollout of solar thermal already. So basically, the project's a $370 billion project, $37 billion per year. It's less than 3% of GDP. It's what we spend today on insurance. This is insurance for our safe, energy secure, climate secure future. And at $37 billion a year, it's cheaper than it's less than what we spend on new cars at $54 billion a year. We can do this. It'll expand the economies in ways we wouldn't imagine, and give us many opportunities to move into emerging markets in Asia, the Middle East and North Africa. Today, Worley Parsons, SKM, companies like that build the world's fossil fuel energy infrastructure. If we don't do this at home, they may not have opportunities to build tomorrow's infrastructure. So we need to learn through doing, because we've really been a part of the global 19th century fossil fuel boom, and we don't want to miss out on the 21st century boom. So at the moment, it's a case of gas or renewables. Plans, here's the AGL's spreadsheet saying we're going to get 10,000 megawatts of combined cycle gas turbine. That's base load gas by 2020 under a $25 to $70 tonne carbon price. We've got to choose whether we go a gas future, which is just a straight carbon price, or a renewables future, which is a carbon price just to block out the coal at $0 to $20, but the heavy lifting, the real work, is done by the renewable energy feed-in tariff, which has been so successful to get us 18,000 megawatts of photovoltaic, almost Australia's entire eastern seaboard generating baseload capacity in PV. It's managed to get solar thermal plants rolled out in Spain. It's got massive cost reductions in those technologies so that people in China can now afford, in Nepal and places like that can now afford medicines in remote locations, because that photovoltaic has come down so much due to that aid program that Germany executed in country, and that is the feed-in tariff. So we can help ride the cost reduction curve. The heavy lifting's already been done by Germany and Spain. It's time to get on with it and to be part of that move of the global economy, the 21st century economy, and Australia should be a part of it. So in parting, I'll just say it's our choice. We can install 1 square metre of mirror surface and not burn 20 tonnes of coal. Or to put it another way, we can choose to burn 20 tonnes of coal and not install 1 square metre of mirror surface. Thank you.